everyone, you're welcome back to Bioscience Class channel. Today is another lesson and we are going to treat a subtopic in enzyme kinetics, and it's how to derive the Lineweaver-burk plot from the Michaelis-Menten equation. Alright, so today basically we are going to talk about the Lineweaver-burk plot. So in enzyme kinetics we have the three types of plots. We have the Michaelis, the Lineweaver-burk plot, we have the Eadie-Hofstad's plot, and we have the Haynes-Wolff's plot. And all these type of plots are derived from the Michaelis-Menten equation. Alright, so before you can derive all these three types of plots, you have to know the Michaelis-Menten equation and how to derive it. So if you don't know how to derive the Michaelis-Menten equation itself, you have to know how to derive it before you can be able to derive the other three types of plots from the Michaelis-Menten equation. So we are going to talk today about how to derive the Lineweaver-burk plot from the Michaelis-Menten equation. So the first step in deriving the Lineweaver-burk plot is to state the Michaelis-Menten equation. So from enzyme kinetics, the Michaelis-Menten equation is given by V, which is the velocity, equals Vmax, which is the maximum velocity, times substrate concentration divided by the Km, which is the Michaelis constant, plus the substrate concentration S. So after stating the Michaelis-Menten equation, let's see what next to do. Okay, so after stating the Michaelis-Menten equation, what you have to do next is to take the inverse of both sides of the equation. Alright, so we had V over here, so it's going to be 1 over V. We had Vmax times substrate concentration divided by Km plus substrate concentration S, the whole equation divided by 1. So in simplifying further, we are going to get 1 over V equals Km plus substrate concentration S divided by Vmax times substrate concentration. So from mathematics, when you have A over B divided by 1, definitely is going to be B over A. So there is going to be a reciprocation. That means the denominator is going to occupy the numerator position and the numerator is going to also occupy the denominator. Alright, so that's what we see over here. We have 1 over V equals Km divided by Vmax times substrate concentration S plus the substrate concentration divided by Vmax times substrate concentration. So as you can see over here, we have substrate concentration times another divided by substrate concentration. So they are going to cancel each other. Alright, so this is going to give us 1 over V equals Km divided by Vmax times 1 over the substrate concentration plus 1 over Vmax. Alright, so this is the inverse of the Michaelis-Menten equation. So after stating the Michaelis-Menten equation and taking the inverse of both sides of the equation, this is where you will arrive. Okay, so after getting here, what you have to do next is to rearrange the equation. Alright, so you have to rearrange the equation in the form y is equal to mx plus c. So this is the equation of a line, y equals mx plus c. So in rearranging them in the form of y equals mx plus x, we are going to get 1 over the velocity, which corresponds to y, equals Km divided by Vmax, which corresponds to m, that's the gradient, times 1 over the substrate concentration, that's the x component, plus 1 over Vmax, that's the intercept c. Alright, so after getting the form y equals mx plus x, let's see what to do next. Okay, so the last step is to make comparison to deduce the y, x component and the intercept as we did already. So by comparing it to the equation of a line, it can be seen that the y component is equal to 1 over the velocity. Alright, so the y component is equal to 1 over the velocity the x component is equal to 1 over the substrate concentration. The gradient m is equal to km over Vmax. Alright, and the intercept c is equal to 1 over Vmax. So this is a graph showing the Lineweaver-burk plot. So this is a Lineweaver-burk plot showing the y coordinate, the x coordinate, and the straight line showing the gradient, and also having the intercept over here. So let's go through the graph. So we have the y component to be 1 over v, 1 over the velocity. So as you can see over here, we have 1 over v. We have the x component to be 1 over the substrate concentration. So it's a straight line. Alright, so the Lineweaver-burk plot is a straight line with a gradient m, which is equal to km over Vmax, as we can see over here, with intercept c, which is equal to 1 over Vmax, as we can also see over here. So the negative intercept on the x-axis corresponds to negative 1 over km. So you can find km also here by taking the negative inverse of this one to get km. Alright, so this is the whole process to derive the Lineweaver-burk plot, and this is the graph showing how everything is on the equation. Alright, so thank you for watching this video. This is Bioscience Class channel. If you've not subscribed to this channel, please make sure to subscribe to get any video alerts. Alright, so the other two types of plots has been uploaded already. We have the Eddie-Hofstad's plot and we have the Haynes-Wolff's plot. So you can also check on that to see how to derive all those types of plots. Have a nice day. Thank you very much.